The goal of this lesson is to help reduce assembly-related bearing failures. 5 important factors of bearing life include applying the right bearing, proper handling and storage of bearings, proper installation of bearings, initial lubrication procedures, and ongoing lubrication practices. The first 4 issues are directly affected by an assembler. This lesson will provide some general guidelines for bearing installation, introduce the concept of bearing preload, and explain the importance of using proper lubrication and handling procedures. Pre-assembly storage is an issue that an assembler may have little control over. 2 things to watch for are damage to the shipping container and unwrapped components. If you see evidence of this, notify your supervisor so the handling process can be examined. Components and containers should arrive undamaged with bearings stacked in the flat position. Storage areas should not have abnormally high humidity or moisture. During the installation process, cleanliness is of utmost importance. For this reason, bearings are always protected from contamination prior to their use. They are usually wrapped in oil-impregnated paper that serves 2 purposes. It protects from outside contamination and also prevents corrosion of the highly polished seating surfaces. You should not unwrap the bearing components until you are ready to assemble them. Contamination in very small doses can be destructive. Since many bearings and components are pressed into place, the fit can be affected by contaminants that are very small. When preparing for bearing assembly, shafts and bores must also be free of dirt or other debris which could cause improper seating or misalignment. These surfaces should be well protected during storage and pre-assembly staging. Use the proper tooling and procedure to install bearings. The tools required may include special drivers. These are often used to drive the bearing cup to a specified depth. Races should be pressed onto shafts or into bores straight, and only through the race being mounted. Never press or drive a bearing through its rolling elements. This could cause chipping of ribs or denting of raceways. There are times when a bearing cup may get slightly cocked and need to be tapped into place to facilitate assembly. A plastic hammer should be used for this purpose. Make sure you do not strike a polished surface. Usually, you will only strike or press the end with bearing information stamped on it. Always use proper tooling and procedures. When 2 parts are assembled with a pressed fit, the differences between their respective sizes is called interference. A bearing may be pressed into a bore that is slightly smaller in size. One way this is accomplished is through the use of a hydraulic-powered bearing press. Bearing components are also heated or cooled to make the installation process easier. Heating bearings causes expansion for installation on shafts. Heating must be done with circulating heat in a thermostatically controlled environment to avoid exceeding manufacturer's specifications. Ovens and oil baths are 2 ways this can be done. Extreme temperatures can soften bearings. Temperatures should not exceed the 230 to 250 degree Fahrenheit range, and the duration should be specified. The use of open flames to heat bearings is forbidden due to the uneven and uncontrolled temperatures generated. Freezing bearings causes shrinkage for easier installation into bores. This is another process that must be controlled to meet specifications. Bearings should be frozen at -40 to -65 degrees Fahrenheit for a specific amount of time before installation. Using colder temperatures can permanently change the size and microstructure of the bearing cup. The assembly process will usually specify a minimum period of time that the bearing cup must be cooled or heated prior to installation. When handling heated or frozen bearing components, protect your hands from the metal surfaces to avoid personal injury. And finally, just before you assemble a frozen bearing cup, make sure you wipe away condensation. Water can contaminate by the oxidation process. Size and alignment of shafts, housings, and bores must be within specified tolerances. Poor quality and fit of these components will cause uneven loading and result in early hour field failures for bearings and major components. As an assembler, you may not be aware of these conditions, but if you encounter problems during the bearing assembly process, this should be investigated. Bearings are installed to control axial and radial loads. Caterpillar often uses two roller bearings installed in opposite directions to control multiple forces within high load components. This involves a process called bearing preload. Preload refers to the initial axial load placed on a set of bearings during installation. That force applied to the bearings allows measurement to determine the size of the shim pack, and the shim pack ensures the amount of compressive forces exerted on the bearing. Using this process eliminates free play within the bearings. It also controls excessive compressive forces exerted through the bearings, which could cause extra wear on the races. During the next few screens, we'll take a close look at the procedure as it is done on the upper hitch of a non-engine frameable wheel loader. This process is similar to applications used with many other machines. The first step is to review the assembly instruction list for the components that will be used. A good practice is to retrieve all the parts that will be used and place them within arm's reach. As previously stated, do not remove protective wrappings until just prior to assembly. The next step is to clean any machine surfaces which may have been covered with a protective layer of grease during the paint process. Any paint, tape, or dirt that has adhered to the machine surfaces must be removed as well. Use a clean, lint-free towel unless you have been provided with special cleaning solutions or kits. Make sure you check the cleanliness of the parts and fasteners that will be assembled as well. You are now ready to install the bearing cups. Remove the cups from the freezer as you are ready to install them in the bore. Be sure to wear gloves when handling them. Usually, these components drop easily into place without a driver. However, you may need to tap the cup to get it in place. Make sure you use a soft hammer and strike on the lip of the outside diameter, not on the bearing face. A driver is a tool used to install bearing components to a specified depth while preventing damage to piece parts. If you do need a driver to install components, always use the driver specified on the assembly documentation. Drivers should be clearly marked with a PX number, which matches the number in the assembly documentation. The driver should be in good condition. If the striking surface has been mushroomed or damaged, the device should be repaired or replaced. In this case, a bottom cap plate is first installed, then the lower outer race is added, followed by the first roller bearing, the second roller bearing in the opposite direction, then the top bearing cup. Any lubricant that is required should be applied to the bearings at this time. Prior to the installation of the top cap plate, shims are installed. This critical step is what determines the amount of preload. A certain thickness of shims will be specified for this step. Using less than the correct amount places a higher preload, while using more shims lowers the amount of preload. An assembler may have to remove shims from the shim pack supplied. When working with shims, protect your hands because the edges are very sharp and can easily cause lacerations to your hands. Then, install the top plate with 3 bolts equally spaced. A locating mandrel is used to ensure bearing alignment with the bore. Run down and torque those 3 bolts, then place a torque checking tool such as this dial torque wrench on the mandrel. The resistance it measures should fall into a certain range, specified by assembly instructions. Factors that impact this resistance are the amount of shims used and the alignment and cleanliness of the components. This operation is called rolling torque. In certain cases, you may need to make adjustments to the assembly. If the rolling torque reading is higher than the specified amount, the addition of some shims will be required. Remove the bolts and upper hitch cap, then add a few shims to the pack. Replace the components and recheck the torque. If the torque reading is lower than the specified amount, the removal of some shims will be required. If the torque meter reading is erratic, the bearing cups are probably not seated or aligned correctly. This can be caused by tightening the bolts in a circular pattern instead of crisscross pattern, or by allowing contaminants to get into the lubricant or piece parts during installation. Inspect them carefully before installation. A good practice is to check the cups for seating prior to assembly of other components. When the torque reading is within the required range, you're ready to complete the assembly process. Remove the adapter and install the remaining bolts, torquing them in a crisscross manner. Torquing bolt patterns properly reduces the chance of poor seating and misalignment, so the bearing will function as required. When used with bearings, the three functions of a lubricant are to separate mating surfaces and reduce friction, to transfer heat, and to protect from corrosion and dirt. Assemblers perform the initial lubrication of many bearings. Clean lubricant and application tools is of utmost importance. A good lubricant must maintain an unbroken layer of film between the metal surfaces. The required thickness of the layer depends on the speed, load, and temperature of the application. For this reason, make sure you use the oil specified by the assembly plan. The viscosity will be correct for the application. Preventing excessive friction is vital to bearing life. Reducing friction limits heat, which reduces wear and increases the life of the bearing. Excessive friction also results in loss of efficiency in the application. Oil and grease are the lubricants used with bearings. Grease lubrication is recommended unless low torque or high speed is essential to the application. Several types of oil such as gear, mineral, and lube oils are used, but the operational life of oil is lower because of evaporative losses. Copgraft, a copper and graphite-based lubricating compound, is commonly used for high-temperature applications that exceed 350 degrees. Some bearings are plated by immersion in an oil or grease, while other types use vacuum impregnation for lubrication. These types may need no additional lubrication during installation. Since bearings are applied to a specific application, you should always consult your assembly operation description to make sure the proper lubricant is being used. Most bearing components are stored with a coating of lubricant that prevents corrosion. The paper they are wrapped in is specially treated with oil to ensure the coating is maintained until the component is assembled. Storage areas should be low humidity. When handling bearings and related components, keep in mind that a bearing's worst enemy is contamination. Contaminants can lodge in crevices and over time lock the bearing, resulting in a spun bearing. The end result will be major component damage. Water is a form of contamination that can be introduced in several ways. Unlike oil, the viscosity of water weakens under pressure, which leads to problems in load-bearing applications. Water can be introduced by condensate from frozen bearings, and it can occur in the lubrication supply itself. Use extreme caution when using compressed air around bearings. Compressed air usually contains high moisture, which can produce corrosion in bearings. Even the moisture and acids from your hand can cause corrosion that reduces bearing life. Cosmetic powders can also be a source of contamination. In general, keep all dirt and foreign material away from bearing components. An issue of safety discussed earlier is the handling of shim packs. This is especially important if you have to separate the individual shims from a pack. Individual shims may be just a few thousandths of an inch thick, making the edge about the same thickness as a razor blade. Another point to remember is the handling of components that have been heated or frozen. Exposed skin can be burned by either hot or cold, so make sure you protect it while working with heated or frozen bearings.